Okay, the directions are to solve the following inequality involving a quotient, and the problem starts 1 plus x over 1 minus x greater than or equal to 1. And the first thing we're going to do is to put all the terms on one side, and we're going to put it on the left hand side, LHS for left hand side. What we get is 1 plus x over 1 minus x, subtract 1 greater than or equal to 0. And then what we need to do next is get a common denominator. And so this fraction right here and this fraction right here need a common denominator. So we're going to move this up out of the way. What we have is 1 plus x minus 1 times 1 minus x over 1 times 1 minus x greater than or equal to 0. And the reason we're allowed to do that is this is the number 1. Then when we write it as a single fraction, we have 1 plus x minus, and we need to be careful here because the item in pink is going to end up being this number right here is going to be negative. This number right here is going to be positive because we're going to distribute this 1 right there, and it's going to end up making those signs change. So then we have it all over the fraction 1 minus x greater than or equal to 0. Then what we have is 1 plus x minus 1 plus x all over 1 minus x greater than or equal to 0. The 1's cancel. We have 1x and 1x, which gives us 2x over 1 minus x is greater than or equal to 0. Then what we do is set the numerator and the denominator equal to 0 and solve. This will give us our critical points. Two x equals to 0 is my first critical point, x equals 0. 1 minus x is equal to 0. The second critical point is 1. Then we take our number line, put 0 and 1 on the number line. We have 3 regions, 1, 2, and 3. We're going to test those. So let's decide first if the boundaries 0 and 1 are open or closed. If you go back and look at the original problem had a denominator of 1 minus x greater than or equal to 1. So for the boundary 0, if you plug it in, you have a true statement because 1 really is greater than or equal to 1. So this boundary right here is closed dot. But when you check the other one, and you have 1 plus 1 over 1 minus 1, you get a 0 on bottom. And we know that's undefined. So x can't be the number 1. So this ends up being an open boundary right there, because I have this right here is going to cause division by 0. So the next thing to do is to test each region. So in region 1, I'm going to test x equals negative 1. I have 2 times negative 1 over 1 minus a minus 1 greater than or equal to 0. And what I get is on the left hand side -1, on the right hand side 0. That's not true. So we see in our first region right here that this was false, so we don't shade it. Now in region 2, let's test the number x equals 1/2. 2 times 1/2 over 1 minus 1/2 is greater than or equal to 0. And what I have is 1 over -1/2 greater than or equal to 0. That's true because it's positive on the left hand side. And so since this is true, we're going to shade this region. Now we're going to test region 3. We're going to test the point x equals 2. We have 2 times 2 over 1 minus 2 greater than or equal to 0. This is 4 over -1 is greater than or equal to 0, but that's not true, so we don't shade region 3. So now what we have is region 3 is not shaded, and that's the graph of our answer. And then what we can do is write that in interval notation, 0, 1, with a bracket on the left and an open parenthesis on the right, and that's it.